Hi, I'm FullDeck.
And I'm missing a few cards, as always.
As you can tell, we're delighted to be here with another puzzle from Maggie and BremSter.
Really looking forward to this one.
Yes,
Can
me
we get
too.
straight to it?
Let's do. Let's go through the rules. This one's called Diamond Mine. And we've got normal Sudoku rules apply. So in every row, in every column, and in every 3x3 box set off by darker shaded lines, we need to place the digits 1 through 9 without repetition.
We have cages. Normal cage rules apply. The digits in the cage have to sum to the number in the top left corner, and digits may not repeat within a cage.
I don't think that oh, here's one. Okay, so here's a cage. I was looking for a cage where that was going to matter. So this is a 13 cage. The digits have to sum to 13. And by ordinary Sudoku rules, those two digits, for example, could be the same. But because they're in a cage, these two digits would have to be different digits. So we couldn't put, say, 1 and 1, and then 5 and a 6. Because even though those sum to 13 and the ones don't see each other by normal Sudoku rules, they do see each other by cage rules. So we can't repeat digits within a cage.
Next, we have parity dots. This is a constraint I haven't done a lot of.
No, but I do like parities.
Yes.
So.
Looks like it'd be fun.
Yeah.
So dots, digits separated by a black diamond have to be the same parity, so both even or both odd. And separated by a white diamond, they have to have different parity.
Okay, so on this dot, it would be okay to have 2, 8 or 3, 7, because 2 and 8 are both even, 3 and 7 are both odd. But on this dot, they'd have to be different. So we'd have to have 2, 7 or 3, 8 or something like that. Okay.
Let's restart the timer.
Let's do. Restart.
Let's give this a whirl.
Let's do. Okay.
I have a suggestion.
Okay, what your suggestion is not, let's take a moment and see what we can spot in the puzzle?
No,
okay.
Let's think about coloring.
I think we definitely want to color. I was going to start thinking about this cage just because box 1 is always a nice place to start. These have to be the same parity. If they are, whether they are both odd or both even, the sum of the two of these is going to be even, because two odds, add 2 odds, you have a remainder of 1 from the first one dividing by 2, a remainder of 1 from the second one dividing by 2, put them together, you've got a multiple of 2. So these two together are going to be even, which means that this one has to be even regardless of whether these are even or odd.
And we could say the opposite in the 10 cage in box 3, because an odd and an even sum to an odd, so the remainder making up the 10 must also be odd.
Okay, and we're gonna use blue for even and orange for odd, just because that's how we started doing it early on, and it's very difficult to teach old dogs new tricks. And we are definitely old dogs. All right, let's keep doing that, because I think that those cages, those are going to be powerful things. So we know here on this white dot, the sum of these two will be odd. To get from an odd to an odd, we need an even.
And that's on a black diamond, so that's
even across this, across the way from it. Same thing over here. This white dot is going to separate an odd and an even, so 1 of each. The sum of these two will be odd. So this one is going to have to be even to keep the total of the 3 cells odd. And now because it's on a black dot, black diamond, it gets a same parity across from it. I'm sure we can do more of that. It's 26 cage. The sum of these two will be even. The sum of these two will be odd. So we have an odd plus an even, which will give us an odd.
Around, but yeah.
Well, I'm sorry, yes, an even over here on the black dot, an even sum, an odd sum on the white dot.
Yep.
Those 4 digits together, don't know what they're going to be, but it's going to be an odd total, and we need to get to an even for the cage as a whole. So this is going to have to be odd.
No, that's odd. That's
odd.
That's
okay,
odd.
Man, you scared me there. Okay, let's go. So even sum. An odd sum gives us an odd sum. We need another odd to get to an even sum. So that one is odd, which means that across from it is odd. Okay. Have we now exhausted what we can do in this first row? I think we might have. In this first set of things. Just quickly within the cages. I think that's all of the cages where we can do a quick and dirty figure out the parity of the remaining cell. Okay, here we go then.
Well, that was fun. Nice
puzzle. Nice puzzle. Okay. Okay, so in the 10 cage, let's go back to box 1. Always a good place to go. So this can't be 8 in row 1, column 2, because if it were 8, this would be at least 3 would be a total of at least 11. So this is either 2, 4, or 6. If this is 6, then these have to be 4 on the black diamond, so that would be a 1 and a 3. They'd both be odd. But if it's 4, we're making 6. It could be.
They could both be even.
They could be both even or both odd. Oh no, because if it's a 4, it can't be 2, 4, right?
Yeah.
So if this is a 6, those are a 1, 3. If this is a 4, those are a 1, 5, because we can't do 2, 4. And if these are a 2 to make 8, it could be 1, 7.
Or 3, 5.
Or 3, 5, but not 2, 6. This is always an odd pair. Oh, that's cool.
Nice.
That's really nice. So that means that this one is even because it is across a white diamond from an odd. So we had to change parity. So we now have 2 evens inside a 13 cage. So the sum of those is even. We need to get to an odd. So one of these is odd and one is even. So it's a split parity. Do we want to color those when it says split parity?
No, maybe.
Not across a diamond. Well, we could, yeah.
Let's not for now.
Let's not for now. Okay.
So the evens in that cage add up to at least 6. So the
wait. Why? These 2 evens add to 6. At least 6. Yes. Agreed.
So the remaining 2 cells add to at most 7.
Yes. I don't know how to track that either. Oh, but I do have a deduction.
What is your deduction?
My deduction is that there is an even on this parity dot. And so then I have a question.
Oh, so
what does that mean for the parity dot, for the black diamond here?
Yep, that's odd.
Yes, because we've used up.
The 13 cage has 3 evens in it.
Yes.
If it were 2, 4, and 6, we'd need 1.
Oh, yes, indeed. So, indeed.
So we know the contents of the 13
yes,
cage.
so these are 2, 4, and from 2, 4, and 6. And these are from 1, 2, 4, and 6. Oh, that was a nice observation. Okay. So now. Now what? So the 8 cage, they will be the same parity because they have to either be both even or both odd in order to sum to an even number. And the 9 cage is going to be one of each because we need an even and an odd to sum to an odd number. So any 2-cell cage that's even, we have to have the same parity inside it. And any 2-cell cage that's odd will have one of each. And that's a useful fact for us to keep in mind. One even here and one odd here.
So definitely not all diamonds are given.
Definitely not all diamonds. You would have a diamond between on each domino to give all of the diamonds. Let's see. What next? We have an odd on this diamond. And that will be our 4th odd. There are 5 odds, 1, 3, 5, 7, and 9. There are 4 evens. So in any row, in any column, or any box, we're going to wind up with 5 orange cells, 5 odds, and 4 evens, 4 blue cells, until we erase the coloring, which we'll probably do at some point. So right now, with this diamond included, we have 4 oranges in column 1. We only get 1 more orange.
So I have a question.
Yes.
In the 13 cage, we have 2, 4, and 6.
Yes.
In column 3, what does that do to the 8 cage? Column 3 must have 1 of 2 and 6 in column 3 in the 13 cage. So that means the 8 cage must be odd.
Oh, nice. Okay, so yes, because this cell sees all of those.
I was thinking the one below it, but that one.
Oh, yeah, actually, this one I think is perhaps easier to see. This cell right here sees all 4 of the 13 cage cells, either in the column or in the box. So this can't be any of 2, 4, or 6. So this is absolutely an orange pair, an odd pair. It's either 1, 7 or 3, 5.
And the other 8 cage in column 3.
This one, yes.
Sees at least one of 2 and 6. So it can't be a 2, 6. So it has to be odd.
Yeah. Okay. Right. If it were 2, 6, this would be a 4, and those would both be 1. So it can't be 2, 6. Yes. So it is odd. Nice. Okay.
So we can color row 7, column 4, and row 4, column 4.
All right. So across a white diamond from
no, we can't do row 4, but we can do 7.
Okay. So across the white diamond from an odd is an even, and we don't know this one yet. But we now have 1, 2, 3, 4 odds in the column. So this is either 1 even and an odd, or it's 2 evens. I'm not sure that helps us at all. Not sure it helps at all. I was kind of proud of it temporarily, but I don't think it was useful. So the 19 cage could be 3 odds, or it could be 1 odd and 2 evens, and
It can't be 3
and
odds.
it can't be 3 odds now, because if it were 3 odds, that would give us 1, 2, 3, 4, 5, 6 odds in the column. So there are 2 evens in the 19 cage, and I am going to let's see. Let's think this through. So 2 evens and an odd. It can't be 2 and 4, because then we would need 13 for the odd. It can't be 2 and 6, because we need 11 for the odd. But it could be 2 and 8, so we can't rule out the 2. It's an odd and 2 evens. We can't even necessarily say that the odd is in this pair, which would be nice if we could, because that would put an even to complete the column right there. But how do we mark? Is there any way we can mark that? We could put O's and E's in, but I'm not sure.
No.
Okay.
So the odd is at least, what, 5?
The odd is...
The most we can get from evens is 6 and 8, which is 14.
Yes, the odd is at least 5, yes.
So there is either a 5, a 7, or a 9.
Yes, which I don't know how to mark effectively.
No.
Oh, but 22 and 19.
19 across it.
I realize that, but that's 41. So 40, and the sum of this entire box is only 45. So these 3 cells have to be offset by that one. So this cell, right, wait, I've gotten myself twisted up now. So here's 41 right there. So whatever this is, if we, help me out with this. How are these related? No, I'm clearly not doing fine. I'm totally tangled up.
Okay, so if we call that cell's value X.
Yes.
Use a letter.
Oh, you want me to actually put a letter in?
Yeah.
I have to go in and turn on letters then. Hang on. I apologize for the overlay in the I don't want the, do I want the letter tool? Okay. So you want me to put in a letter. So we're going to call this
A.
X. Wait. There we go. X. Calling it X.
Okay.
Okay. So these, I'm a mathematician. I should be able to do this, but somehow this is just freaking me out. So I'm gonna use some colors for a second. These cells, the yellow cells, plus these 3 equal 45.
Yep.
The yellow cells plus X equal 41. So if I take away the yellow cells, well, 45 minus the yellow cells is this, and 41 minus the yellow cells is X. Oh my gosh, why can't I do this? So 41 yellow cells. I need a pencil and paper. I can do this so easily on pencil and paper. Talk me through it. I feel like an absolute numpty right now, but no, I don't need an actual piece of paper. I can do this. I am capable. Okay. By the way, for all of you out there saying, "Oh, but they're mathematicians; they must be able to do all of this so easily," or if you're questioning your own math ability,
laugh at us.
Laugh at us. Have fun. It's all good. Okay, so I'm gonna. When in doubt, also, if you're really tangled, it's always helpful to try actual numbers. So if these three cells summed to, say, 4, then because these would all be 45 together, that would mean that our X would have to be 0. So that did it for me. These three cells have to sum to 4 more than X.
Yep.
See? I knew I could get there. It was just a temporary thing. So these three cells are 4 more than X. That doesn't do as much as I was hoping it would. All of that effort in putting my struggles on display, it didn't really give me a whole lot.
X is at least 2.
Well, yeah, X is at least 2, but we already knew that X had to be at least 5. So, well, no, we knew the odd had to be at least 5. It could be 2. Yeah, you're right. Could be 2, 8, 9. Yeah, so X is at least 2, and those three cells are at most 13 taken together. Yeah, that doesn't really do a whole lot for us. I have completely sidetracked. You know, BremSter has to be just cackling at the moment, and also probably frustrated that we're not seeing what he clearly intended here, because we go off on these tangents. This 13 cage right here?
No, the 13 cage in
this
box
13.
6.
Okay.
Because it has 2 evens and an odd.
Yes. So if it were 2 and 4, we would need a 7. If it were 2 and 6, making 8, we'd need a 5. And so it can't be any more than 7. But we could, so 1, 3, 5, or 7. Any of those will work, but not.
Yeah. And then we've got the 15 cage.
Wait, why wouldn't 9? Oh, because we need another even in there, yeah.
So there's something going on, I think, between the 15 cage in box 4 and the 13 cage
15
in box
cage
6.
in box. Oh, yes, probably. So these two.
We can colour the rest of the row.
Can we?
We've got 4 evens in the row.
Oh, for Indeed, we can. Sorry, BremSter and Maggie, for missing the completely blind obviousness and going off onto some weird sidetrack here. Okay, so I'll cross a white diamond from an orange is a blue.
Okay, now that 15 cage needs another even, because it's got 3 odds.
These two would make even. This makes odd. We need to stay odd. So yes, that's even. Across from even is even across a black diamond. Okay. So now these are at least 1, 3, 5, which is only 9. So this is at most 6. So this is 2, 4, 6. Could it be a 2? Sure. 13. Okay. Okay. Now what?
We have to have 2 odds and an even in the 24 cage. In addition to the 2 evens, we've got
2 odds and an even.
Because we can't put 5 evens in there.
We cannot. You're right. So we have two odds in here and an even. So we'll have 1 more even in this box. Huh. This 15 cage right here in box 5 has 1 odd. In order to make an odd in 3 digits, they can either all 3 be odd, or it could be an odd and 2. I know, I'm trying to explain the whole reasoning. Give me a second. So it could either be all 3 odds, or it could be an odd and 2 evens. And since we already have
3
4 odds showing up. We can't put 2 more odds in this cage, so
Yep.
those have to be even.
So
And
those have to be odd.
Yep, those are odd, which
And we can put a
places the
digit.
1. Oh my gosh, our first digit. Woo! Okay, so that's a 1. That is not a 1. It is even. That is actually going to prove to be probably quite helpful indeed. Okay, this 19 cage now has an odd and an even, so the sum of these 2 digits is odd. We need to stay odd, which means that the sum of these 2 digits needs to be even. So they are either both even or both odd. And then whatever is across the black diamond from it will be the same. I don't know what they are, but these are the same. And this is the opposite. Sorry to add more colors, but I just want to keep track of the fact that those are all the same and that's different, and I don't know which is which yet. Okay, our last even for box 6 is used up on this white dot. We have 1, 2, 3, and the 4th blue is going to be there. So these are both odd, and in a 2-cell tin cage with 1 odd, the other one also has to be odd. So across from it on a white diamond is even.
So those 2 are odd.
So this sum is even. The sum of these 2 has to be even, and it can't both be even, so they both have to be odd. And that gives us our 5 odds for column 5. Starting to make some progress. Oh, that's helpful. Because these 2 are even, and there's a 3rd even on the white diamond.
Those 2 have to be odd.
Those 2 have to be odd. Yes, excellent. And
so that means the row 1, column 6 is even.
Even, and to make an odd sum in 2 cells, you need, 1 even and 1 odd. Excellent. Okay. Now, we will have an even on the white dot in box 2 in column 6. That will give us all 4 evens for the column.
Good.
These 3 are odd.
Yep. Row 6, column 4 is even.
Row 6, column 4. Ah, yeah. Good. 5 odds already in the box. Okay.
So the 2 15 cages add to 30, so the remaining 2 cells have...
I'm sorry, which 2 15? Oh, these, right?
Yep.
These, okay, yes.
And so the remaining 2 cells have to add to 15, so they're either 7 8 or 6 9, so that's a 6 8.
6 8 and 7 9. Yeah, so 6 would go with a 9, 8 would go with a 7, that's good. Oh, row 4. 5 odds.
Nice.
That's even. Complete the row. And now, 4 evens in column 2. These are all odd. That's beautiful. I like it when they just smoosh the rest of the row on. Okay. So, oh, this 8 cage can no longer be 1 7, but it's 2 odds. It's a 3 5. And that means that this 8 cage can't be a 3 5. It has to be a 7 1, and the order is known because there's already a 1 in column 3.
Very nice.
Slow but steady wins the race. This cannot be a 9 in a 2-cell 9 cage, so it's either a 3 or a 5. If it's a 3, it goes with a 6. If it's a 5, it goes with a 4. In the 10 cage, we also can't put a 9, so this is either a 3 or a 5. Because it's a 3-cell 10 cage. If it were a 2-cell 10 cage, we could have put a 9. That may be important for this, because if this is a 3 5, since this is a 3 5 pair, if those 2 cells in the 19 cage in box 3 were odd, they would be at least 1 and 7.
Maybe 7 and 9, because we have an odd in the 10 cage, and we can't put a 7 or a 9 in there.
Oh, yeah. It would be 7 and 9.
In the 10 cage, in fact.
Wait, hang on. Oh, right. Right. Okay, backing away from the 19 cage. You're right. The 10 cage is much more important. We have to have an odd. 3 and 5 are used up. We can't put a 7 in a 10 cage with even a 3 at another cell. So there is a 1 in here. One of those is a 1. Now, if it's 1 and 3, that would be 4. We'd need 6. If it were 1 and 5, that would be 6. We'd need 4. So this is a 1, 4, 6. And one of them is a 1. Okay, good. And because the 1 is here, there's no 1 there. That's at least a 3, 5. So it has to be a 3, 5 with a 2.
Very nice.
Thank you. I was pleased with that.
Yeah.
So that takes 2 out of those 2 cells, but those 2 cells are in a cage with the 2, 4, 6 triple. So it places a 2 at row 5, column 3. Oof. And now these 2 are at least 4 and 6. So this is at most 5 now.
So it's a 3 or a 5.
And because it can't be a 1. So it is 3 or 5. So these are either 4, 6 or 4, 8. And there is a 4 in there because 6, 8 would be too much. So this one is either a 6 or an 8 to complete the box, whichever one is not in here.
And that means that the 8 is in column 2.
8 is in column 2. Oh, yes. No. Yes. Oh, okay. Of the 4 evens, the only place for the 8. Yeah. Nice.
So it's not in column 1.
Yeah. Very nice. And then we've got 1, 3, and 5. So that's a 7, 9 pair. We've got a 3 and a 5 pair. So this is 1, 7, 9. Low-hanging fruit being much appreciated at the moment. Okay. So now the lowest that this cell could be would be 4. At row 5, column 7. That's at least a 4. Which means that these 3 cells in the 19 cage are at most 15. This is at least a 3 because it sees a 1. So we've got at least 7 here. But this could still be, yeah, that doesn't rule things out. I really want that 19 cage to break open.
If the green is odd,
yes,
then it's a 7, 9 pair.
Right,
which
16.
is 16. How do you make 3 in the remaining?
Yeah, we can't. Okay, so these are even. So all of these are even. That's nice. Okay. That's odd. So this is the 1. All right. Good.
And the 2 blue cells there are 2 and 8.
Okay, convince me of that.
There's a 4 and a 6 in the row.
Oh, yeah. Okay. Okay, so these, we now have 10 in the cage. These sum to 9. If that's if the even is a 4, it can't be a 2 because there's a 2 in the row. We would need a 5. If this is a 6, we would need a 3. And this cannot be an 8, both because there's already an 8 in the cage and because an 8 would need a 1 and there's a 1 in the row. So multiple reasons there. Okay. I feel much better now that the 19 cage. Well, and now that the 19 cage is a little bit more restrained. We have a 3, 5 pair in the column, so this cannot be 3, 7 in the 2 cell 10 cage, so it has to be 1, 9. 5, 5 doesn't work. Let's see. So in this 13 cage, we have either 1, 7, or 9. Go ahead.
18 cage in column 7.
18 cage. Column 7, 18.
Has an odd in it.
And that odd is a 7. Well, there's...
No.
I see what you're saying.
It has an odd in it already, so it needs one more odd, one more even. That's going to give us 3 evens for the column. Row 2, column 7 is even.
Nice. Yes. Yeah. Yeah. We have to have an even and an odd to get our parity. Yep. Excellent.
And
so
these are
it is a 4,
4,
6. Okay.
So
Oh, we do know there's a 7 in here.
The remaining 2 cells in box 3 are odd and are 7, 9 and are placeable in box 3.
Box 3. Yes, we have 4 evens. Okay, good. So those are odd.
There's a 7 in row
1, 3, 5, and 7 are all seen here. So that's a 9 and that's a 7. Excellent. So this is a 3, 5. This is also even because we now have all 5 odds for row 1. And that gives us all 4 evens in box 1.
Now, back to the 13
wait,
cage.
can we finish this real quick? Because I can do more things. Because this 1 looks across, and so the only place for 1 in box 1 is there, and the only value left for this odd is 9. The only value left for this odd is 7. Okay, your turn again.
Okay. In the 13 cage, in box 6.
Box 6, yes.
We can't use a 9. Because that would leave us to make 4, and we can't do that with 2 blues, especially when 2's ruled out. So where does 9 go in box 6? Oh no, it could be 2 places. Never mind.
I'm not seeing the...
No, I'm wrong.
Okay, okay.
We can finish colouring rows 2 and 3 though.
Okay, 1... Oh, yes, there are all of our evens in row 3. So that is odd, and across from it is even. Like, this is a 2-8 pair right there because there's a 4-8.
And we're going to determine what it is because we can pencil mark, center mark, row 3.
Row 3 is 3, 5, 9.
Yes.
And so 3, 5, 9 is 17. 17 and 7 is 24. This better be a 2.
Yep.
An 8. And let's go ahead and place our 8 in row 1. Okay. So now, this is a 2, 4, or 6, just for fun. And this is a 4, 6, or 8, because it sees a 2 in the column. We don't have a 3 or a 5 available in the 13 cage. And because of the 3, 5 pair in the box. And this cell also cannot be 1, 7, or 9 because it sees 1, 7, and 9 in the column.
Very nice. So
that's even. This one's odd.
And in fact, it is 1 or 7.
So it sees a 3, 5.
And it can't be a 9.
And it can't be a 9, yes. So 1 or 7.
And we're left with the remaining odd cell as a 7 or a 9.
Nice, and that gives us a 7, 9 pair in the row, as well as a 1 in the row. So this is either 3 or 5. Okay, if this...
And it can't be a 3, because that would need a 6 and an 8 to go with it. Oh no, sorry, ignore me. It would need a 4 and an 8.
4 and an 8,
yeah.
Could it be a 5? That would leave us with needing 10. Could be a 2 and an 8, or a 4 and a 6. Okay. Let's look at this. So if row 6, column 8 is a 7, then we're missing 6, and it would have to be 4, 2 in that order because we already have a 2 in the row. If it's 1, we're missing 12, which would have to be 8 and 4. So this is 4, 8, and that's 2, 4, 8. So, and 2 is in this column. Okay, we have 4 odds showing up. One of those 2 is an odd.
So that's even. So the 25 cage either has 3 evens and an odd, or it has 3 odds and an even, and it can't have 3 evens, can it? Because there's another one in there.
One of these is even. If it were 3 evens, we'd have one in this pair,
And one in that pair.
and,
That could
and
work.
those would both be even. That would work. Could it be 3 odds? That would mean that all 3 of these are odd, and that's odd, and that's odd, and that would work too. Actually, it wouldn't. If this were 3 odds and an even, then all 3 of those would be odd. Oh, it would work. It would work. It would mean that this would have to be even because of the row, but that could be odd, and that would do it. That works. Never mind. Okay.
Oh, look at column 3.
Look at column 3. Ha!
Those are even.
It needs 2 evens, yes. And a 19 cage does need an odd, so that's the odd. And these are taken from 4, 6, and 8.
It can't be 4, 6. There must be an 8 in it.
You're right. You're right. It can't be
already.
4, 6. It could be 4, 8. It could be 6, 8. Yes. So
it's either 5 or 7 to finish the cage.
Thank you. That's exactly what I was about to do. So let's try to figure out what could go there.
I think the X can go away now. Maybe.
I think it probably can. Yes. That was. Well, you would think it could. There it goes. Okay. So what else? This 22 cage. If this were a 1, 7, that would get us to 8. We'd need 14, which would have to be a 6, 8, which it can't be because there's an 8 in the column. So this cannot be 1, 7. If it were 1, 9, we would need, that would be 10. We'd need 12 here, which would have to be 8, 4, which it can't be. So there's no 1 in those cells. This is the 1. And so these are making 16, which means we're missing 6, and this has to be a 2, 4 pair.
Okay, that resolves the 4, 6 in the column.
Which gives us the 6 in the box makes that an 8. 6 and 8 in the box make that a 4.
And that needs 5 to go with
and
it.
Then, yes, we 5 to complete the 15 cage. The 5 looks right, gives us a 3. The 3 looks down and gives us a 5. And what are we missing
3.
for the... Thank you. 3.
Which resolves the 3,
which
5.
looks up, which cleans up that. Excellent. I'm going to make that orange. Odd.
The 4 in column 2 looks up. Resolves
4 in
1.
column 2. Nice. 6. Oh, we have a complete box. Okay, and the 4 looks down, clearing out the 4s here, giving us a total of 14 in the 19 cage. So we need a 5. 5 looks up, takes the 5 out from row 4, column 3.
And we can finish coloring box at 8.
Yes, we can, because we have 5 oranges already in box 8. So that is an even. Okay. In row 7, the odds that are missing are 1, 7, and 9. This cell sees 1, 7, and 9. It has to be even.
Very nice.
That's odd. And this is odd, which means this is odd for the parity of the cage.
Nice.
That was beautiful. This is, I mean, you keep saying nice, and it's really the construction of this puzzle that's giving it so beautiful. It's just lovely use of parity. We have 5 odds in row 8, so this one is even. Below it is odd and 7.
We've got the coloring.
The fully colored grid. Excellent.
Okay, we can get rid of the coloring.
No, we most certainly cannot get rid of the coloring. Not until we get center values anyway. And these two have to be 3 and 9 because we have 1, 5, and 7 for our odds in the row. So these are 1, 7.
In the 18 cage, if it's a 3, we would need 8 more.
Yes, so that we would need 8 there.
Or if it's a 9, we'd need 2.
2. So that gives us a 2, 8 pair, which is fortunate because we already had a 4, 6 pair in the column, and we probably could have just gone ahead and marked in the 2, 8, but we didn't. The most we can get from 3 evens is 4, 6, and 8, which would be 18. So these have to be at least 6. So we can't, well, actually we could have the 1 and the 9 or the 3 and the 7. That doesn't really help clear anything out. Ignore that. 359 triple in column 5 places a 1 7 to complete the column in the digits. We've got 1 5 and 7 in column 4, so this is a 3 9. Okay, where do we have cages that we can make use of?
Maybe the 4 in row 5 would be helpful.
The 4 in row 5. Yeah, you think the 4 looking right to clean up the 6, the 6 and the 8. And this 8 in the 13 cage takes the other 8 out. Also, it's in the box. We know we had to have a 2 in that
and
cage.
8 and 7 would be blowing the total by a lot. So
yes, well,
the odd is a 1.
We've got a problem then. Hang on a second.
Yes, because you should have had a 4.
Yes, it should be a 4. The 2, there is a 2 in the column, but it's up there, yeah. So, and that's the 2. 8 and 4 is 12. That's the 1, giving us 13. 1 looks left. 9 looks down. 9 looks left. The 7 in the box gives us a 1. The 1 looks down. We resolve the 7, 1. The 7 looks left, resolving the 9, 7. Oh, this is going to just open up massively now. The only 2 odds left in the row are a 3 5 pair. The only odd left in this row is a 9. So
which
we now
looks up.
Okay, I was actually going to do 9 and 8 is 17, so we're missing an 8.
Okay.
9 looks up, good. 7. 7 looks left to the 9, which looks down to the 7. This 8 in box 9 gives us a 2. 2 and 7 is 9, meaning 9 more to make 18. 9 looks left.
So that gives us 10 in the 24 cage. We need
10.
14
Oh, yeah,
more.
we do. So how do we make 14 from 3 evens? 8, 2, and 4 works, and that's the only choice, yes. So there's no 6 here. There's no 6 there. This is a 2, 4, 8, and that is a 6.
Which looks left.
Which looks down. We could have. So now evens left in the row are of row 9 are 2 and 4, but there's a 2 in the box. So this is a 4. That's a 2. The 2 looks left to make a 4. In box 9, we're missing a 6. The 6 in column 4 looks up. The 8 looks back down.
15 cage in row 4.
Okay, hold that thought. We now have a 2 4 pair here that's going to give us an 8. Okay, now you were saying
The 2 4 pair. 15 in there needs a 4 and a 6, so it's a 5.
Excellent. Complete the sum of 15. Good.
5 looks right.
Okay, we also have a 3 9 pair here, which gives us a 5 in that box. 5 looks right, giving us the 3. Good.
Looks up.
Looks up. 5 looks right. 3 looks
9
down.
cage needs a 4.
9 cage.
Row 1.
Ah, yes. 4, and the 4 gives us the 6. The 3 in column 9 looks up to give us a 5.
The 3 in column 5 looks up to resolve box 2.
3 in column 5 looks up. Good. 9 and 3. The 3 looks down. This 15 cage, we're now at 10, so we need another 5, and we can't use 2 and 3, so it has to be 4. I mean, it has to be, I said that backwards. We can't use 1 and 4, we need 2 and 3. Exactly what he said, but I was being an umpty. 2 looks down, cleaning that up. The 6 looks up. This 2 looks up to give us an 8 and a 2.
And the 4 looks up in column 8.
4 looks up, 6 and 4. And that is the correct solution to Diamond Mine.
Puzzle.
That was really fun. I really liked, it was just gorgeous. Absolutely gorgeous. And using the parity, I was actually expecting when we first got started for there to be more cages where we could use diamonds inside cages to determine parity of a missing cell, but it was much more intricate than that. That was really, really lovely. Absolutely stunning puzzle. And
could we get more?
I do too. Me too. And parody. I mean, I know that BremSter loves parody. Maggie clearly loves parody. We love parody. So this was just absolutely a delight. Thank you so much. And as Brem always says, good luck with your solving.